Welcome to the DIY Honda Garage channel. DTC P0113 indicates a malfunction related to the intake air temperature (IAT) sensor circuit in the Honda Accord from 2012 to 2017. The IAT sensor plays a crucial role in the engine management system by measuring the temperature of the air entering the engine, allowing the powertrain control module (PCM) to adjust the air-fuel ratio for optimal combustion. This sensor is a thermistor that changes its electrical resistance depending on the temperature of the intake air. As the temperature of the intake air rises, the resistance decreases, resulting in a lower output voltage. Conversely, if the intake air temperature drops, resistance increases, leading to a higher output voltage. If excessively high voltage is detected on this sensor circuit, the PCM interprets it as a malfunction, thereby triggering code P0113. The IAT sensor is typically located in the intake manifold or near the air duct, making it accessible for diagnostics and repair. In conclusion, understanding the role of the intake air temperature (IAT) sensor is crucial for maintaining optimal vehicle performance in the Honda Accord from 2012 to 2017. DTC P013 signifies a malfunction in this vital circuit, emphasizing the need for a systematic approach to troubleshooting. Effective diagnostics will begin with wiring inspections, progressing to voltage and resistance checks of the sensor itself, ensuring abnormalities are swiftly addressed. Furthermore, implementing regular maintenance can significantly prevent issues related to the IAT sensor, thereby enhancing the longevity and reliability of the vehicle. Following these guidelines will not only keep the vehicle running smoothly, but also ensure compliance with emission standards, ultimately benefiting both the environment and the user. The intake air temperature IAT sensor detects the temperature of the incoming air into the engine. This information is crucial for the engine's air-fuel ratio management, which ensures the engine runs efficiently and reduces emissions. The IAT sensor is typically a thermistor placed in the intake manifold or immediately after the air filter, where it can accurately assess the temperature of incoming air. It provides real-time data to the PCM, allowing for adjustments to fuel injection and ignition timing based on the density of the air. This adaptability is essential, especially under varying atmospheric conditions. If the IAT sensor notices a high voltage signal indicating a fault, the PCM will trigger a diagnostic trouble code, DTC, to alert the driver or technician of a potential issue. The potential causes for DTC P0113 can include several issues. Firstly, an open TA line can result in a discontinuity between the IAT sensor and the PCM, leading to incorrect voltage readings. Secondly, an open SG line may also lead to improper functionality by interrupting the signal sent to the PCM. Thirdly, a failure of the IAT sensor itself can occur due to factors such as age, environmental wear, or manufacturing defects. Finally, less commonly, an internal circuit failure within the PCM can result in incorrect processing of the sensor's data. It's important to assess these possibilities methodically to ascertain the root cause of the DTC. The symptoms associated with DTC P0113 typically include an illuminated check engine light, MIL, indicating that the PCM has detected a fault. This error can lead to poor engine performance, which may manifest as rough idling, stalling, or difficulty accelerating due to improper air-fuel mixture adjustments. In addition, there can be an increase in engine emissions, which is particularly concerning for environmental regulations and overall vehicle operation. These symptoms can also lead to reduced fuel efficiency, as the engine may work harder to compensate for improper readings. Therefore, prompt attention to this DTC is critical to maintaining optimal vehicle performance and compliance with emission standards. The first troubleshooting step for DTC P0113 is to inspect the wiring leading to the IAT sensor. This includes checking for any visible damage or wear that could result in a faulty connection or an open circuit. It is essential to examine the connectors for any signs of corrosion or debris, which can interfere with the electrical contacts and lead to erroneous voltage readings. The integrity of the connections must be confirmed, as loose or damaged connectors may cause intermittent faults. A multimeter should be used to measure continuity in the TA and SG lines, ensuring that the circuit is closed and operational. This initial diagnostic will provide valuable insights into whether the issue lies in the wiring, the connectors, or further downstream in the sensor itself. The second step involves measuring the voltage output at the IAT sensor itself. With the ignition in the on position, use a multimeter to check the voltage against the manufacturer's specifications. For a properly functioning IAT sensor, the voltage should typically be within a specific range. Values exceeding 4.92 volts indicate a potential fault. Additionally, measuring the resistance of the sensor can assist in determining if it's functioning correctly, with a particular focus on confirming that high resistance is not present. If the voltage and resistance values deviate from their specified ranges, the sensor may need to be replaced to restore proper function. This diagnostic approach will clarify whether the IAT sensor itself is faulty or whether an external issue is causing high voltage readings. The third step in the troubleshooting process is testing the functionality of the IAT sensor itself using a scan tool or multimeter. If previous steps indicate that the sensor's voltage is out of specifications and resistance testing fails, replacing the sensor is likely necessary. Ensure that the new sensor is compatible with the Honda Accord model year you are working on, as variations may exist between years and trims. Once the IAT sensor has been successfully replaced, it is critical to clear the DTCs using an appropriate scan tool. This action resets the PCM, allowing it to reevaluate the new sensor's performance over subsequent drive cycles. Make sure to drive the vehicle to allow the diagnostic system to confirm proper function, which will aid in ensuring that the replacement resolved the issue and no further DTCs are set. After completing the repairs, it's essential to verify that the problem has been resolved effectively. Begin by rescanning the vehicle for any active diagnostic trouble codes, DTCs. Verify that P0113 no longer appears. Additionally, monitor the operation of the new IAT sensor during a test drive. Ensure that the voltage output falls within the specified range and that the air-fuel mixture adapts appropriately under various driving conditions. Continuing to monitor the engine performance for any irregularities is essential to confirm no reoccurrence of the issue. Performing a thorough verification process is critical not only for customer satisfaction, but also to prevent the same issue from arising in the future. Implementing preventive maintenance practices can significantly reduce the chances of encountering DTC P0113 in the future. Regular inspections of the IAT sensor and associated wiring should become part of routine vehicle maintenance. Checking the condition of the connectors is also crucial. Clearing any dirt, debris, or corrosion from the contacts can help maintain a stable electrical signal. Additionally, being proactive about addressing any performance issues can prevent more serious problems later on. This can involve keeping tabs on engine performance and addressing any noticeable changes promptly. Preventive maintenance not only enhances vehicle performance, but also extends the life of critical components like the IAT sensor. Please like and subscribe to the channel. See you next time.